Hello dear students, let us discuss our physics questions. Our first question, surface tension has the same dimension as that of, here 4 quantities are given. From this any one of them have same dimension of surface tension. So the answer is spring constant. Spring constant and surface tension has same dimensions. We can write the equation of surface tension S equal to F divided by L, force per unit length is the surface tension. Also the equation of spring constant K equal to F by X, force by displacement. Okay, here in our both equations the numerator contains force, their dimension is mlt raised to minus 2. Their denominator having here length, also here displacement, so both have the dimension L. So in our question, surface tension and spring constant have same dimensions. Second question, if force F, length L and time T be considered as fundamental units, then units of mass will be, suppose a new system of units in which the three fundamental quantities are force, length and time. So we can express the mass in terms of these three fundamental quantities. Okay, for this we can use the applications of dimension analysis. We can derive an equation for a quantity by using their dependent quantities. From this first step we can derive equation for mass. So we can write mass in m, that's proportional to their fundamental quantities are F raised to X, then L raised to Y, T raised to Z. This is the first step. Okay, in our second step we can write this relation in terms as an equation by multiplying a constant. So m equal to mass m equal to, that's a constant K, into F raised to X, L raised to Y, T raised to Z. Okay, in our third step we can substitute their dimensions and simplify it. What is the dimension of m? M is the mass, so the dimension is capital M. Here K is dimensionless constant, then force m L T raised to minus 2 all raised to X. Here L is the length, so the dimension is L raised to Y, time T raised to Z. Okay, this is the dimension of each sides. So we can simplify this. Here m is here, then m raised to X, L raised to X plus Y, T raised to minus 2X plus Z. Then fourth step we can equate the powers of each dimensions. Here first we can equate dimension of m. Here the power of m is 1, here x, so we get the value of x as 1. Similar way, next we can equate the dimension L. So here power of L is 0, here x plus y. From this we get y equal to minus x, so value of x is 1, so y equal to minus 1. Next we want to equate the power of dimension t. Here power of dimension is 0, in RHS minus 2x plus z. From this z equal to 2x, so 2 into 1 equal to 2. So these are the values of x, y and z. Okay, then these values can be substituted in our second step. Second step is an equation. Okay, that is mass m equal to a constant into F raised to X, L raised to Y, T raised to Z. Substitute the values of X, Y and Z in this equation. So we get m equal to, this is the fifth step, m equal to the value of constant, suppose 1. 1 into f raised to x, here 1, L raised to y here minus 1, t raised to z here 2. So this is the dimension of m can be written as f raised to 1, L raised to minus 1, t raised to minus 2. Here we want to write the dimensions. So dimension of m equal to f L raised to minus 1, t raised to minus 2 is the correct answer. So our option is f L raised to minus 1, t raised to minus 2. Option C is the correct. Here printing mistake is the having a power here t raised to minus 2, t raised to 2, sorry, t raised to 2. This is the dimension. Okay, so correct answer is option C, f L raised to minus 1, t raised to 2 is the answer. Next question. If increase in linear momentum of a body is 50%, then change in its kinetic energy is, here we want to find the percentage error of the kinetic energy. In this question, initial momentum and final momentum are connected by using some percentage. So this sentence can be written as, if increase in linear momentum of a body is 50%, so it can be written as the final momentum, that can be written as Pf, equal to initial momentum plus 50% of initial momentum. This is the equation. Pf here, Pf equal to Pi plus 50% of Pi. So this can be simplified. Pf equal to 1 plus 0.5 into Pi. Okay, also can be written as 1.5 Pi. This is the relation connecting initial and final momentum of the body. Here we want to find the change in kinetic energy of the body. So we can write equation for change in kinetic energy in percentage error like this. Delta Ke divided by Ke into 100. This is the standard equation of changing kinetic energy. So it also can be written as Kef minus Kei. This is the change in kinetic energy, final kinetic energy minus initial kinetic energy divided by initial kinetic energy into 100. This is the equation for finding the percentage of the kinetic energy. So substitute the values of Kef here and Kei here and simplify. We can write the relation connecting kinetic energy and momentum is that kinetic energy equal to P square divided by 2m. Here Ke proportional to P square. 2m is a constant, 2 and m are constant. Substitute this relation here. So we can simplify. Kef can be written as Pf, Pf square, Ke proportional P square. So Kef equal to proportional Pf square minus Pi square divided by Pi square into 100. Okay. Next, the value of Pf square, Pf is that 1.5 into Pi square minus Pi square all divided by Pi square into 100. So Pi square can be cancelled from our numerator. Pi square is common, so that can be taken out, so that Pi square and denominator Pi square can be cancelled. So remaining part is 1.5 square minus 1 into 100. What is the value of 1.5 square? 2.25 minus 1 into 100. Okay, that is 2.25 minus 1 means 1.25 into 100. So answer is 125%. This is the correct answer, 125%. Okay, next question. The coefficient of friction between the tires and the road is 0.25. The maximum speed with which car can be driven round a curve of radius 40 meter without skidding is, assuming g equal to 10 meter per second square. So our answer options are 20 meter per second, 15 meter per second, 10 meter per second. Here also 10 meter per second. Maybe mistake is there, printing mistake is there. So we want to find the maximum speed of the vehicle when it turn a level curved road. Here we know that the equation for finding the maximum velocity during the turning motion or a level curved road is Vmax equal to root of mu r g. This is the equation. So here root of mu is the coefficient of friction, that is given here 0.25 into r is the radius of the curve. So here 40 meter. So 40 into value of acceleration to gravity is 10 here. So we can simplify this, equal to here 25 into 4. Okay, 40 contain 10, here also 10, so 100 can like this. So 5 into 2 equal to 10 meter is the correct answer. Here in our question, option C and option D also are 10 meter per second. So maybe a mistake is the correct value is 10 meter per second. Here not meter, because it's a velocity. Here, velocity is meter per second. Meter per second. This is the correct answer. Okay. Next question. Block A of mass 2 kg placed over a block B of mass 8 kg. A figure is given. This is a surface in which a 8 kg body is there. Another body A, that's mass 2 kg over the 8 kg body. The combination is placed over a rough horizontal surface. Coefficient of friction between B and the floor is 0.5. That is given. Coefficient of friction between B and the floor. Here, value of here coefficient. Value of coefficient of friction between surface and B is given 0.5. Mu equal to 0.5. Next, coefficient of friction between block A and B is 0.4. Here friction mu equal to 0.4. A horizontal force of 10 Newton is applied on the block B, that's shown in figure. The force of friction between block A and B is given that G equal to 10 meter per second, 10 meter per second square. We want to find the force of friction between block A and B is, we want to find the frictional force between the two bodies A and B here. I want to find that value. First of all, here a 10 Newton force is applied on the block B. So a frictional force acting on this side F, we can write F1 here, force of friction F1. So first we want to find the value of force of friction F1 here. Force of friction F equal to mu N. N is the normal reaction. So we can write mu into mg. This is the equation of force. N is the normal reaction. In downward, their weight mg. So upward, for normal reaction N. So here, force of friction F equal to mu N. N from this figure, N can be written as mg here. M is the total mass of the system. Total mass of the system here 8 plus 2, 10 kilogram. So substitute the values here. F equal to value of mu here 0.5 into M, total mass is 10 into 10. Okay, so 50 Newton is the force of friction between the 8 kilogram surface and surface of the 8 kilogram and the surface. is the force of friction is F1 equal to 50 Newton. But here we only apply a 10 Newton of force, but the force of friction is 15 Newton. So this body cannot move through over the surface, because here force of friction is very large compared to the applied force. So the body does not move over the surface. So it has no kinetic friction. Kinetic friction means friction during motion. Here no motion is there, so friction force is 0. So our answer is 0, because this body does not move over the surface. Why? The force of friction is very much greater than the applied force. So the system does not move over the surface. So force of friction between these two surfaces are 0. Okay, next question. A force F acting on an object varies with the distance x as shown here. The force is in Newton and x is in meter. The work done by the force in moving the object from x equal to 0 meter to x equal to 6 meter is. Okay, we want to find the work done by the force from where x equal to 0 to x equal to 6 meter. So here force displacement Fs graph or force displacement graph is given. The area of force displacement graph is equal to work done. That is the concept here. The area of force displacement graph is work done. So the concept, that concept is used to determine the value of work done from the Fs graph. So area of the Fs graph, area of the Fs graph or Fx graph, area of the Fx graph equal to work done. So we can find the area from x equal to 0 to x equal to 6. This is a trapezium. What is the area of trapezium? So that is work equal to area of the trapezium. Area of trapezium is half h into a plus b. Here two parallel side is there. Small one is taken as a and large side is b. The distance between these two parallel sides is taken as h. Here w equal to half into value of h here 3 to 0. 3 into a plus b. A is here 3 plus b is here 6. So we can write this 3 by 2 into 9. So 27 by 2 is here. 27 by 2 is 13.5 joule is the answer. 13.5 joule is the answer. Okay, next question. A thin rod of length L and mass M is bent at a midpoint into two halves so that the angle between them is 90 degree. Not percentage, 90 degree. This is the angle. The moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane defined by the two halves of the rod is. Here, first of all, a rod is there having length L, mass M. That is bended into their midpoint. So we can draw like this. Like this. Suppose first of all this is a big rod, then their midpoint will be bent like this. Angle between them is 90 degree. Okay. The moment of inertia, we want to find the moment of inertia of the bent rod about an axis passing through the bending point. Suppose an axis like here, we want to find the moment of inertia of this system. Okay, suppose like this is a first rod, this is bending rod like this, an axis like this. This axis lies the plane define the the moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane. Okay, like this. So one of the bending rod, this is another one. It's an axis that passing through the point of bending and perpendicular to the plane. Okay, so here we consider two rods having length L by 2. Okay, having length L by 2. Length L by 2. Also mass M by 2. Here also mass M by 2, length L by 2. There one of the end is fixed on the axis. So we can write their moment of inertia is ml square by 3. This is the standard equation. A rod of length L, mass M, and axis of rotation is at their end. Then the moment of inertia of their rotation is ml square by 3. That is the standard equation. So that equation can be written here. Standard equation is this. Moment of inertia I equal to ml square divided by 3. But here total moment of inertia I equal to I1 plus I2. This is a standard equation. I1 plus I2. That is I equal to I1 moment of inertia of the first rod. So their mass is 1 by 3 is here common. Mass is m by 2. Length L by 2 the whole square. Okay, plus I2 is the moment of inertia of the second body. Similar way, 1 by 3, m by 2, mass is here m by 2, length L divided by 2 the whole square. So we can write I equal to 2 into 1 by 3 into m by 2 into L square divided by 4. So our equation, just ml square by 12 is the correct answer here. ml square by 3 into 4. That's what. ml square divided by 12 is the correct answer of these questions. Okay, next question. A ball rolls without slipping. The radius of gyration of the ball about an axis passing through its center of mass is k. If radius of the ball be r, then the fraction of the total energy associated with its rotational energy will be. A ball is rolling without slipping. A pure rolling is there. Pure rolling motion is there. Their radius of gyration is k and radius of the ball is r. So there during their rotation, that ball consists of rotational kinetic energy and translational kinetic energy. That is the total kinetic energy of the body is sum of rotational kinetic energy and translational kinetic energy. So here we want to find the ratio of rotational kinetic energy divided by total kinetic energy. We want to find KE rotation divided by KE total. Okay, so can we write KE rotation divided by KE rotation plus KE translation. So right, total kinetic energy is the sum of rotational kinetic energy and their translational kinetic energy. So we can substitute the values here. Half I omega square is the standard equation of rotational kinetic energy. Translation means half mv square plus half rotation half I omega square. This is the standard equation. By solving this, half cancel. Here moment of inertia is not given, so we can write moment of inertia I equal to mk square. This is the equation of the moment of inertia when mass and their radius of gyration is given. So I equal to mk square. Also v or omega equal to v by r is the radius, v by r. Substitute these values here in this equation. We get half are cancelled. In the place of I we can substitute mk square into, in the place of omega, v by r the whole square, all divided by half mv square plus, sorry, half not here, half are cancelled, mv square plus I omega means mk square into v square by r square. Okay. from this m can be cancelled. M can be cancelled. Also v square can be cancelled from the k square by r square. What is the value here? Divided by 1 plus v square by r square. So k square by r square here, by cross multiplying this, r square plus v square divided by r square. So the in terms of reciprocal, r square divided by v square, sorry, it's not v, it's a k. It's not v. K square by r square. We are cancelled. K square plus r square. Okay, r square are cancelled. So our final answer is k square divided by k square plus r square. This is the correct answer. K square divided by k square plus r square. Okay. Next question. At what height above the surface of Earth the value of acceleration due to gravity would be half of its value on the surface of Earth? Here radius of Earth is 6,400 kilometer. Okay, we want to find the value of height at which the acceleration due to gravity is half of that of Earth. So we can draw like this. Suppose it's Earth of radius r. At a particular height h, we want to find the value of h here, at which acceleration due to gravity is g by 2. Acceleration due to gravity on the surface of Earth is g. At this point is g dash. G dash equal to g by 2 is given. Okay, we want to find the value of h here. Okay, we can write the equation g equal to gm divided by r square is the standard equation of determining the value of acceleration to gravity. This is the acceleration to gravity on the surface of Earth. So at a height gh equal to gm divided by r plus h the whole square. This is the two equations connecting acceleration due to gravity on the surface of Earth at a height. So just divide these two equations, we get gh divided by g equal to, here denominator is the r square divided by r plus h the whole square. Okay, value of g dash is, here I am writing g dash, that is gh equal to g by 2. So substitute the value of g by 2 here. G by 2 g are cancelled. So here 1 by 2 equal to r square divided by, r divided by r plus h the whole square, like this. Square, take their square root here. 1 by root 2 equal to r divided by r plus h. From this r plus h equal to root 2r. So h equal to root 2r minus r. So root 2 minus 1 into r. What is the value of root 2 here? 1.414. So 1.414 minus 1 into value of r is 6,400 kilometer. So 0.414 into 6,400 equal to, we get the correct answer is 2650 kilometer. Option B is the correct answer. 2650 is the correct answer. Option B is the correct answer. By multiplying 2650 is the correct answer, that kilometer. Okay, this is the correct answer. Next question. A rectangular vessel when full of water take 10 minutes to be emptied through an orifice in its bottom. How much time will it take to be emptied when half filled with water? Okay, this is a question from fluid. You know this concept. Suppose this is a vessel the surface area of the free surface. Okay, area of the open surface is A and it contains liquid. Okay, and orifice is there. Suppose their area equal to A0. Water will flow through them and take T equal to 10 minutes to complete these filled water through this orifice. Okay, height of the vessel is H. Height of the liquid, not vessel, height of the liquid is H. So time taken to complete liquid through this orifice equal to A by A0 into root of 2H divided by G is the standard equation to find out the time. T equal to A by A0 into root of 2H by G. A is the area of the surface area of the open surface, area of the orifice. H is the height of the liquid here. Okay. First of all, in a vessel containing completely filled water, that take 10 minutes to empty through that orifice. So we can write this equation 10 equal to A by A0 into root of 2H by G, equation number 1. Similar way, in other sentence, how much time will it take to be emptied when half filled with water? In that case, height will be reduced to the half of the initial. So in next case, time T equal to A by A0 into root of 2H by 2 divided by G. This is the equation 2. By just dividing these two equations, we get T by 10. So equation 2 divided by equation 1. A by A0 are cancelled, H are cancelled, here 2 also cancelled. So final answer is root of here 1 by 2 is there. Other are cancelled, 1 by 2 is there. So we get our answer T equal to 10 divided by root 2. This is the answer in our option. 10 by root 2. 10 divided by 1.414. So we get 7 minutes is the correct answer. 7 minutes. 7 minutes. Okay, this is the answer. 7 minutes is the correct answer. You know this equation, time T equal to A by A0 into root of 2H divided by G. That is the correct equation to determine the time. Okay. NR. Next question. A faulty thermometer has its fixed point marked as 5 degree and 95 degree. The temperature of the body as measured by the faulty thermometer is 59 degree. The correct temperature of the body on the Celsius scale is, options are given. Here we want to connect a new thermometer and with thermometer of degrees Celsius. So what is the standard equation connecting these two thermometer? This is the correct equation is T minus lower fixed point divided by upper fixed point minus lower fixed point equal to, in the case of Celsius scale, the value Tc minus 0 divided by 100 minus 0. This is the relation connecting temperatures in Celsius scale and in faulty thermometer. Okay, every thermometer has a lower fixed point and upper fixed point. That based on the water ice, in the case of water ice point and their boiling point. In Celsius scales, ice point of the water is 0 degrees Celsius and boiling point of water is 100 degrees Celsius. Corresponding in new faulty thermometer, that is lower fixed point, upper fixed point, like this. So we can write in faulty thermometer standard equation like this. It's a constant. Is a constant. Okay, by connecting these two temperature scales, we can write T, that is 59, minus lower fixed point is 5 divided upper fixed point 95 minus 5 is the values of faulty thermometer. Tc minus 0 divided by 100 minus 0. By simplifying this, we want to find the value of Tc here. So we can write here 59 minus 5 equal to 54 into 100. Okay, divided by 95 minus 5, that is 90. That is the value of Tc here. Okay, 54 by 9 equal to 6. 6 into 10 equal to 60 degrees Celsius is the correct answer. Next question. If 150 joule of heat is added to a system and work done by the system is 110 joule, then the change in internal energy will be. It's a question from thermodynamics. Here, amount of heat is added. So, in the case of amount of heat is added means we want to take the positive sign. So, delta Q is here. Delta Q equal to plus 150 joule here. Okay, a system and work done by the system means system it will expand. So delta W equal to plus 110 joule. Here we want to find the change in internal energy delta U here. According to first law of thermodynamics, delta Q equal to delta W plus delta U. From this, delta U equal to delta Q minus delta W. Here values are given 150 minus 110 equal to 40 joule is the correct answer. So option A is the answer. Next, at what temperature will the oxygen molecule have same root mean square speed as hydrogen molecules at 300 Kelvin? Okay. We know the equation of RMS speed, Vrms equal to root of 3RT by M. Okay, M is the molar mass of that gases. Here two gases is given, one of oxygen and other one is hydrogen. Both gases having same Vrms. So we can write Vrms of oxygen molecule, oxygen gases equal to Vrms of hydrogen gas. So we can connect this equation here. Root of 3RT divided by M of oxygen for oxygen equal to root of 3RT divided by M for hydrogen. 3R will be cancelled. Temperature of the hydrogen is given here. Hydrogen molecule at 300 Kelvin is given. So substitute the values. T divided by molar mass of oxygen is 32 equal to here temperature 300 Kelvin divided by hydrogen 2. So T equal to 32 into 300 divided by 2. That is 16 into 300 equal to answer is 4800. That's the answer in Kelvin. Okay. Next question. for monoatomic gas, which is correct? You know, Cp, Cv are the specific molar specific capacities at constant volume, at constant pressure. Cp by Cv is known as gamma. Gamma equals Cp by Cv. So we want to check the Cv, Cp or Cv by Cp for monoatomic gas here. Okay, this is already wrong options, because Cp minus Cv always R, it's not 2R. So always wrong options. We want to check the value of Cp, Cv or Cv by Cp for monoatomic gases from this. Okay, first we want to write Cv. Cv equal to R by gamma minus 1 and Cp equal to gamma R divided by gamma minus 1. Okay, by substituting the values here, what is the value of gamma for monoatomic? 5 by 3. Substitute here, 5 by 3 into R divided by 5 by 3 minus 1 here. So by simplifying this, 5 by 5R by 3 is here. By cross multiplying this, 5 minus 3, that is 2. 2 by 3. So here 2. So correct answer is 5R by 2. Cp equal to 5R by 2 is the correct answer. So option B is the answer. Cp equal to 5 by 2R. Next question. An SHM is represented by, the displacement relation is given, x equal to 5 root 2 sine 2 pi t plus cos 2 pi t. The amplitude of the SHM is, here displacement is in terms of two trigonometry functions. So that means it's the superimposing wave. Their displacement is x. Okay, we can split that equation like this: x equal to 5 root 2 into sine 2 pi t plus 5 root 2 into cos 2 pi t is the two waves. These two waves are superimposed, then we will get the final displacement is x here. Okay, how can we find the amplitude of the resultant wave? By using the equation, amplitude of resultant wave A equal to root of A1 square plus A2 square plus 2A1 A2 cos phi. Cos phi is the phase difference between two waves. Here A1, A2 are the amplitudes of two waves. That is, here A1 is here. This is A1. This is A2. But phi not directly not given from this equation. We can find the value of phi. So here first one, trigonometry function in terms of sine, here cos. We want to make these two functions are in same function, or either sine or in cosine. So first you convert this sine into cos. That is x equal to 5 root 2 into cos. How can we write sine in terms of cos? You know this, sine x plus pi by 2 equal to cos x. This is the relation connecting sine and cos. Sine x plus pi by 2 equal to cos x. So this function is in cos, that converted into sine. So x can be written as like this: x equal to 5 root 2 sine 2 pi t plus 5 root 2. Instead of cos, we can write sine x plus pi by 2. So sine in terms of x here 2 pi t plus pi by 2. Now the two functions are in same trigonometry function sine. Here sine 2 pi t is there. Sine 2 pi t is there. What is the phase difference between these two waves? Here phase is initial phase is 0. Here initial phase is pi by 2. What is the difference between these two? That's pi by 2. Substitute all the values in this equation. We get A equal to root of, what is the value of A1? A1 here 5 root 2. 5 root 2 all square plus A2 also 5 root 2 the all square plus 2 5 root 2 into 2 5 root 2 into cos pi by 2. This is the values are substituted in this equation. Cos pi by 2 equal to 0. So these terms can be neglected because that value is 0. Finally we get A equal to root of here 2 into 5 root 2 the whole square. So can we write root 2 into 5 root 2. So answer is 5 into 2 equal to 5 into 2 equal to 10 is the correct answer. 10 meter. 10 meter. So now our question, which one is the correct option? That is option A, 10 centimeter, because here displacement is given in centimeter. So our final answer also in centimeter, not in meter. Finally answer in centimeter. Okay, here displacement are given in centimeter, so our final answer also in centimeter. Okay, next question. A pipe open at both ends produces a note of frequency F1. Okay, this means an open pipe is here. Their fundamental frequency is taken as F1. What is the equation for finding the fundamental frequency of the open pipe? That is, general equation is that nu n equal to nv divided by 2l. Here the value of n is 1. So we can write F1 equal to V divided by 2L. This is the given equation. Next, when the pipe is kept with 3/4 of its length in water. Okay, the figure like this. So vessel containing water, a tube, the total length 3/4 of its is filled with water. The remaining portion is 1/4 is contains air. So in second case, this pipe is a closed pipe because one end filled with water, another is open. So it's a closed pipe. What is the general equation for finding the frequency of the from the closed pipe? Nu n equal to n plus half into V by 2L. This is the standard equation. Here n equal to 1. Also length L equal to 1/4 L. Okay, because total length L, there 3/4 of that length is filled in water. Remaining portion is 1/4 L. This is length L dash equal to 1/4 L. So we can write frequency F2 equal to here V divided by 4 into what is the value of length? 1/4 L. So 4 are cancelled. We want to find the ratio of F1 by F2 is F1 by F2 equal to, what is the equation for F1? V by 2L into, we can multiply with their reciprocal, that is L by 4. L by V, not 4, L by V. So our answer is 1/2. So F1 by F2 equal to 1/2 is the correct option. That is option C is the correct answer. Okay. Next question. Two identical metal spheres charged with plus 12 microcoulomb and minus 8 microcoulomb. So, microcoulomb are kept at a certain distance in air. They are brought in contact and then kept at the same distance. The ratio of the magnitudes of electrostatic force between them before and after contact is. Okay, here we want to find the Coulomb force between two charged spheres. Okay, first of all, two identical metal spheres charged with plus 12 microcoulomb and minus 8 microcoulomb are kept at a certain distance in air. So the force between them, F1 equal to 1 by 4 pi epsilon 0 plus 12 into minus 8 Q1 Q2 divided by R square is the standard equation. Coulomb force F equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. This is the standard equation to find the value of Coulomb force. So multiply this 1 by 4 pi epsilon 0. Here, what is the value of 12 into 8? Not equal to into. What is the value of 12 into 8? 96 divided by R square. This is the magnitude, not direction. Plus into minus is minus. What is the magnitude for is 1 by 4 pi epsilon 0, 96 by R square. Okay. Next, in second case, they are brought in contact and then kept with the same distance. Now these two spheres are comes in contact like this. This is having a sphere having plus 2 microcoulomb plus 12 microcoulomb, and another one is minus 8 microcoulomb. What is the total charge of the system? Q net equal to Q1 plus Q2, that is 12 plus minus 8 equal to 4 microcoulomb. This is the net charge when they are comes in contact. After separation, this contains equal charge distribution. So total charge is here. So it only contains 2 microcoulomb. Also here 2 microcoulomb. After their contact, they will share equal charges. Okay, 2 microcoulomb here, 2 microcoulomb here. Also distance between them is similar distance R. So what is the force between them? F2 equal to 1 by 4 pi epsilon 0 2 into 2 divided by R square, that is 1 by 4 pi epsilon 0 4 divided by R square. This is the second equation. Now we want to find the ratio of the magnitudes of electrostatic force between them before and after contact. Before their contact, the magnitude of force is 1 by 4 pi epsilon 0, 96 by R square. After their contact, force magnitude of the force F2 equal to 1 by 4 pi epsilon 0, 4 by R square. Okay, so their ratio F1 by F2 equal to 1 by 4 pi epsilon by R square are cancelled. So 96 divided by 4. What is the correct answer? 24 by 1. So answer is 24:1 is the correct answer. Next question. The electric potential at a point in free space due to a charge Q coulomb is Q into 10 raised to 11 volt. The electric field at that point is, suppose a charge is here, value of charge is Q. We want to find the electric field at a point having distance R. Here electric potential V is given, Q into 10 raised to 11 volt. We want to find the value of electric field at that point. Okay, what is the equation of electric field? E equal to 1 by 4 pi epsilon 0 Q divided by R square. But distance are not given from our question. For but potential at that point is given. So from our equation, potential V equal to 1 by 4 pi epsilon 0 Q by R. This is the standard equation of electric potential at a distance R from the charge Q. From this, R can be written as R equal to 1 by 4 pi epsilon 0 Q divided by V. Okay, 1 by 4 pi epsilon 0 Q divided by, what is the equation of V here? Q into 10 raised to 11. So Q will be cancelled here. So finally we get R equal to 1 by 4 pi epsilon 0 into 10 raised to 11. Substitute the values here. We get E equal to 1 by 4 pi epsilon 0 Q divided by, value of R is 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0 into 10 raised to 11. So 1 by 4 pi epsilon, there all square is there. U by R square. R square is there. 1 by 4 pi epsilon, 1 of the 4 pi epsilon 0 is cancelled. So remaining E equal to Q divided by 4 pi epsilon 0 into 10 raised to 11. This is the answer. So option is Newton per Coulomb is the unit of electric field. So our answer is 4 pi epsilon 0 into Q into 10 raised to 22. Here square is there, 22 is there. Square is 10 raised to 11, all square means 10 raised to 22. Newton per Coulomb. So answer is option A. Volt per meter also the unit of electric field. Newton per Coulomb or volt per meter are the units of electric field. So option 1 is the correct answer. Next question. Identify the false statement. Okay, some statement is given. We can find the which one is wrong statement. Statement A. Inside a charged or neutral conductors, electrostatic field is 0. That is correct statement. There is no net charge inside the conductors. Next question, next option. The electrostatic field at the surface of the charged conductor must be tangential to the surface at any point. It's a wrong statement. The correct statement is, suppose a charged conductor. Suppose a charged conductor, uniformly charged conductor. Suppose this positive charge. We know what is the direction of electric field from the positive charge. So always outward, not tangential. So always outward means perpendicular to the surface. This is the correct statement. But here given that the electrostatic field at the surface of the charged conductor must be tangential, not tangential, say normal to the surface. This is correct, but so this option B is the wrong or false statement. Next question. In the circuit shown in the figure, the potential difference across 4.5 microfarad capacitor is. Okay, a circuit is given from this 3 microfarad and 6 microfarad, not 8. 3 microfarad and 6 microfarad are in parallel. So it has a equivalent capacitance. That equivalent capacitance also series with this 4.5 microfarad. This total system is connected to a 12 volt battery. We want to find the potential difference across the 4.5 microfarad capacitor. We want to find the voltage. Potential difference means voltage. Voltage across this capacitor. What is the equation of potential difference across the capacitor? The standard equation equal Q equal to CV or V equal to Q by C. V equal to Q by C. This is the equation for finding potential difference across a capacitor. Here capacitance is given 4.5 microfarad, not coulomb, microfarad, but charge not given. First of all, we want to find the charge flowing through these capacitors. So what is the equivalent capacitance of this arrangement? Here 3 microfarad and 6 microfarad are in parallel. So equivalent capacitance Cp equal to C1 plus C2, that is equal to 3 plus 6 equal to 9 microfarad. Okay, this first step. Then the equivalent capacitance of these two is 9 microfarad. That 9 microfarad is series with 4.5 microfarad. So equivalent capacitance here 9 microfarad and 4.5 microfarad are in series. So their equivalent capacitance 1 by Cs equal to 1 by C1 plus 1 by C2. Here 1 by 9 plus 1 by 4.5. 4.5. So it's a common denominator, can we make 9? So 2 by 2. Final answer is 3 divided by 9. So Cs equal to 9 by 3 equal to 3 microfarad. This is the equivalent capacitance of the circuit. Then now we want to find the charge through capacitors. How can we find? Charge Q equal to CV. Here equivalent capacitance is 3 microfarad into 3 into micro means 10 raised to minus 6 into 12 volt. 36 into 10 raised to minus 6 coulomb of charge will flow through each capacitors. Okay, we can go to our equation or our questions. We want to find the potential difference across the 4.5 microfarad capacitor. V equal to Q by C. Substitute the values here. What is the value of Q here? 36 into 10 raised to minus 6 microcoulomb divided by capacitance is 4.5 into 10 raised to minus 6 farad. Charge in coulomb is 36 into 10 raised to minus 6. Also capacitance in farad is 4.5 into 10 raised to minus 6 is the. So answer is 36 by 4.5. Question number 22. Line of force due to Earth's horizontal magnetic field are. We know that the horizontal magnetic field lines always parallel and straight. So our correct option is option A is the answer. Answer is 8 by 1, that is 8 volt is the correct answer. Option D is the answer. Next question. Two concentric circular loops of radii R and 2 are carrying current of 2I and I respectively in opposite sense. That is clockwise in one coil and counterclockwise in other coil. Okay, we can draw the figure like this. Two circles, concentric circle. First one is this, radius R, flowing current is 2I. Another circle, concentric circle is there, radius 2R, flowing current, this is anti-clockwise, so this clockwise I. What next question? The resultant magnetic field at their common center is. What is the value of magnetic field at the center? Okay, you know, current carrying circular loop is act as a magnetic dipole. So magnetic field at their center, general equation for finding the magnetic field at their center, B equal to mu 0 I divided by 2R. Okay, substitute this equation in the two circles, in the case of two circles. First one B1 for this circle. Okay, mu 0 into, what is the value of current there? 2I divided by radius is R, so 2R. 2 will be cancelled. Mu 0 I divided by R is the magnetic field. What is the direction of magnetic field due to the current carrying loop in anti-clockwise? That can be found by using thumb rule. Okay, curl our fingers in the direction of current like this. So thumb indicate the direction of magnetic field. Here current in anti-clockwise, so our fingers are turned in this direction. Thumb indicate out of the plane. So magnetic field out of the plane, that is dot, out of the plane. Direction of magnetic field is out of the plane. Next, magnetic field due to the current carrying circular loop, B2 equal to mu 0 into, what is the value of current? Is the I divided by 2 into radius. What is the value of radius? 2r. So mu 0 I divided by 4r. Equation number 2. Next, we want to find the direction of magnetic field, because magnetic field is a vector quantity. We want to find the total magnetic field at their center. We can use superposition principle, that is their direction also must be added to the resultant. So what is the direction of magnetic field here? Direction of current is clockwise, so our right hand fingers are in the direction of current. Thumb indicate the direction of magnetic field, so direction of thumb into the plane, so direction of magnetic field is into the plane. These two magnetic fields are in opposite direction, so net magnetic field can be written as net magnetic field B equal to B1 plus minus B2, because both magnetic fields are in opposite direction. Take one of them is in positive, so their opposite magnetic field is taken as negative. B equal to, what is the value of B1 here? Mu 0 I divided by R plus into minus is minus, mu 0 I divided by 4R. So mu 0 I divided by R is common here. 1 minus 1 by 4, that is 3 by 4. So final answer is 3 by 4 into mu 0 I divided by R. This is the correct option. Answer is 3 by 4 mu 0 I by 4 is the option C. Next question. For an isotropic medium, B, mu, H and M are related as, where B, mu 0, H and M have their usual meaning in the context of magnetic material. You know what is the relation connecting these terms? Option D is the correct answer. This is like this: an object, a magnetic material, so it has already a magnetic field B0. Now this magnetic material is placed in another external magnetic field region. So thus external magnetic field is known as magnetizing field. Due to that magnetizing field, an induced magnetic field is formed inside the magnetic material. Okay, suppose a material is a magnetic material. Now it is already a magnetic material, so it contains a magnetic field is V0. Now it is placed in external magnetizing field H. So it also exerts another induced magnetism B. BM. So net magnetic field B equal to B0 plus BM. Okay, you know this, H equal to B0 by mu 0. So from this, B0 equal to H into mu 0. Write this, B equal to mu 0 into H. Next, BM. BM is the induced magnetic field due to magnetization. So BM is directly proportional to intensity of magnetization M. Mu 0 is the magnetic permeability, H is the magnetizing field, M is the intensity of magnetization, B is the magnetic field. So from this, BM equal to mu 0 M. Substitute here, BM can be written as mu 0 M. So general equation, B equal to mu 0 into H plus M. This is the correct answer. A magnetic material, it has magnetic field B0. That material is placed in a magnetizing field. So magnetization will be there. Another magnetic field will be induced. Net magnetic field B equal to B0 plus BM. Substitute their values here. So we get option D is the correct answer. Next, question number 24. An aeroplane having a wing space of 35 meter. The length between the two wings, L is given here. L equal to 35 meter. Due to north with speed of 90 meter per second. That moving with a speed V equal to 90 meter per second. Given magnetic field at that region B equal to 4 into 10 raised to minus 5 Tesla. These are the given quantities in our question. The potential difference between the tips of the wings will be. This is similar to motional EMF because the wings of the aeroplanes are metals. Length between the two wings are given. They will move with velocity in a magnetic field region B. So, an induced EMF will be formed across their wings. That motional EMF E equal to BLV sin theta. Here sin theta equal to 1. So, E equal to B 4 into 10 raised to minus 5 into L is 35 into velocity is 90. So, our final answer is EMF E equal to option B is the correct answer. 0.126 volt. This is the option D. So, motional EMF across the tips of their wings E equal to BLV sin theta. Here theta equal to 90 degree because aeroplane having wing space 35 meter flies due to north with speed 90 meter per second. Okay, so speed along north. Magnetic field along east-west direction. So, the angle between that directions are 90 degree. So, sin theta, sin 90 equal to 1. So, we can write these two. Okay. Next question. An AC voltage is applied to a resistor R and an inductor L in series. If R and the inductive reactance are both equal to 3 ohm, the phase difference between the applied voltage and the current in the circuit is, okay, a standard equation finding the phase difference between current and voltage in AC circuit is tan inverse XL minus XC divided by R. This is the standard equation. A circuit contains resistor, inductor and capacitor. XL is the inductive reactance, XC is the capacitive reactance, R is the resistance. Here no capacitive reactance is there, so XC equal to 0. Also XL and R equal to 3 ohm. Substitute values here. Phi equal to tan inverse 3 by 3 equal to tan inverse 1. So answer phi equal to 45 degree. 45 degree means pi by 4 rad. Pi by 4 rad. This is the correct answer. Okay. 3 by 3 is 1. Tan inverse 1 equal to 45 degree. Phi equal to 45 degree. So in terms of rad, pi by 4 rad. Next question. Light travel in two media A and B with speed 1.8 into 10 raised to 8 meter per second and 2.4 into 10 raised to 8 meter per second respectively. Then the critical angle between them is, what's my critical angle? During the total interreflection, the angle of incidence is critical angle. That is, suppose this is the separate surface that separates between two media. Suppose this is denser medium, here a rarer medium. When a light obliquely passes from rarer medium to denser medium, denser medium to rarer medium, and light is obliquely passes from denser medium to rarer medium at an angle greater than critical angle, it will rebound into same medium. This phenomenon is known as total interreflection. this is the angle of this is the normal angle of incidence if critical angle. So the refracted ray will passes through the over the surface. So angle of refraction equal to 90 degree. At a critical angle, the particular angle of incidence is critical angle at which refracted ray will be passes through the surface of the media. So angle of incidence equal to critical angle C, angle of refraction equal to 90 degree. Substitute the Snell's law is there. Snell's law, sin I by sin R equal to N2 divided by N1 equal to V1 by V2. N1 is the refractive index of first medium. V1 is the velocity of the light in that first medium. N2 is the refractive index of second medium. V2 is the velocity of the light in second medium. So here velocities are given. We want to find the value of critical angle here. Substitute here sin I divided by sin 90 equal to V1 by V2. So what is the value of I here? C. Sin C divided by sin 90 equal to 1 equal to what is the value of V1 and V2 in our question? Value of V1 is speed 1.8 into 10 raised to 8, that is 2.4 into 10 raised to 8. 1.8 and 2.4. 10 raised to 8 will be cancelled. So sin C equal to 3 by 4. Okay, so C equal to sin inverse 3 by 4 is the correct answer. So in our option sin inverse 3 by 4 is the correct answer. So option D is the answer. Next question. A plano-concave lens is made of glass of refractive index 1.5 and the radius of curvature of its curved surface is 100 centimeter. What is the power of the lens? You know, power of the lens means reciprocal of focal length. In our question, a plano-concave lens is the plano-concave lens like this. Okay. Some values are also given. Refractive index of lens N equal to 1.5. First surface is a plane. What is the value of radius of curvature of plane? R equal to infinite. Here radius of curvature of curved surface R is given. R equal to 100 centimeter. Here the R2. Sign of the R2 is positive because radius of coverage of second surface towards the right side. So it is taken as positive. Then we want to find the value of the power of the lens. Power of the lens means reciprocal of the reciprocal of the focal length 1 by f. You know lens maker's formula n2 minus n1 divided by n1 into 1 by r1 minus 1 by r2. So substitute all the values here. N2, here two media. The first medium is air. So refractive index equal to 1. Second medium is glass. The refractive index is 1.5. So we can substitute 1.5 minus 1 divided by 1 into 1 by infinite minus 1 by 100. So answer 0.5 into 1 by infinity equal to 0. So 1 by minus 1 by 100. So answer is here 0.5 minus 0.5 into 10 raised to minus 2. Now our focal length in meter, then we can write power in diopter. So this is the reciprocal of focal length in centimeter inverse, right? Here value of radius of coverage 100 centimeter, not converted into meter. So here centimeter inverse. So final answer minus 0.5 into 10 raised to minus can be converted into meter, 10 raised to minus 2. So minus all raised to minus 1 is there, 10 raised to minus 2 is there. How can we convert centimeter into meter? 10 raised to 2 meter all raised to minus 1. So 10 raised to minus 2 meter, 10 raised to minus 2 into minus 10 raised to 2, thus can be cancelled. Minus 0.5 meter inverse is known as diopter. So answer is minus 0.5 diopter. Answer is minus 0.5 diopter. Option B is the correct answer. Next question. A cylindrical lens is required to correct which defect? You know, myopia. Myopia means short-sightedness. We can see near object clearly but cannot see distant object. Okay, myopia. Hypermetropia, this is the reverse of myopia. We can see distant object clearly but cannot see nearby objects. Presbyopia is due to aging. Astigmatism can be solved by using cylindrical muscles. Astigmatism is due to imperfection in the structure of the lens. So that be corrected by cylindrical muscles, cylindrical lens. So cylindrical lens is required to correct astigmatism. Okay, next. Question number 29. An electron and a proton are moving in the same direction with same kinetic energy. Here, two particles, the electron and proton, both have same kinetic energy. So kinetic energy of electron equal to kinetic energy of the proton is the ratio of their de Broglie wavelength associated with the particle is, you know, equation of wavelength of de Broglie wave, h divided by p, that is h divided by root of 2mke. This is the standard equation finding the wavelength of the de Broglie wave, h by root of 2mke. Substitute the values. Here we want to find the ratio of de Broglie wavelength of electron and proton. So by substituting this, h divided by root of 2m electron ke electron into root of 2mp into kep divided by h. All the constants can be cancelled. Kinetic energies are equal. So lambda E divided by lambda P equal to root of MP divided by ME is the correct answer. So option C. Next question. The wavelength of the first line of Lehman series for hydrogen atom is equal to that of the second line of Balmer series for hydrogen-like ion. The atomic number Z of hydrogen-like ion is. Here two spectrum is there. First one is Lehman spectrum and second one is Balmer series, Balmer spectrum. In the case of Lehman spectrum, their general equation for spectral series 1 by lambda equal to RZ square into 1 by NF square minus 1 by NI square. Okay. First, hydrogen-like ion, so their hydrogen, so their atomic number Z is 1. Their first line means NF equal to 1 and Ni equal to 2. So for hydrogen, Z equal to 1. Substitute all the values in this equation. We get Lehman spectrum 1 by lambda equal to R into 1 by 1 square minus 1 by 2 square means 4. This is the first relation. In second case, the second line of Balmer series for hydrogen-like ion. So 1 by lambda equal to hydrogen-like ion, so it has an atomic number Z. So R Z square into 1 by second line. So Balmer means NF equal to 2 and Ni equal to 4. Balmer series like this is a ground state. First level, N equal to 1, N equal to 2, N equal to 3 and N equal to 4. Okay, in the case of Balmer spectrum, all the electrons will end on the second level. So this is first Balmer line, this is second Balmer line. So in this case n equal to 4 and n equal to 2. So substitute these values here. 1 by 2 square minus 1 by 4 square. So 1 by lambda equal to r z square into 1 by 4 minus 1 by 16. Question number 2. By comparing these two, 1 by lambda for both cases are same, because in our question the wavelength of the first line of Lehman series for hydrogen atom is equal to that of the second line's Balmer series. So 1 by lambda are equal. So we can equate their RHS. So we get R into 1 minus 1 by 4 equal to R z square into 1 by 4 minus 1 by 16. So R will be cancelled. Here 3 by 4 is there. 3 by 4 equal to z square into 3 by 16. 3 will be cancelled. So 4 will be cancelled in 4. From this, z square equal to 4. So z equal to 2. So atomic number of hydrogen like ion is 2. Question number 31. Two nuclei have their mass number in the ratio of 1:3. The ratio of their nuclear densities would be, density of the nucleus for different nucleus are always same. It's a constant. Density of the nucleus remains constant. You know this? So density of every nucleus are same. That is, so ratio is 1:1. That's the answer. Okay. What is the value of density of each nucleus? 2.3 into 10 raised to 17 kilogram per meter cube is the standard value. That's same for all the nucleus. So 1:1. Next, in a common base configuration, transistor circuit, it's a semiconductor circuit, IE, emitter current IE equal 1 milliampere, IC, collector current IC equal 0.95 milliampere. The value of base current is, the equation connecting these three currents, IE equal to IB plus IC. This is the relation connecting current in transistors. IE is the emitter current, that is IB is base current, IC is the collector current. Here we want to find the base current IB. So IB equal to IE minus IC. Substitute the values directly. 1 milliampere minus 0.95 equal to 0.05 milliampere is the correct answer. Option B is the answer. Okay. Next, common emitter amplifier has voltage gain of, voltage gain means AV. AV equal to 50. Input impedance of, input impedance means R in, resistance 100 ohm. Here ohm is there. And an output impedance is 200. Output impedance means R out equal to 200 ohm, not Fi, say ohm. The power gain of the amplifier is, we want to find the power gain AP. What is meant by gain? What is the standard equation of gain? Gain means output quantity divided by input. Voltage gain equal to output voltage by input voltage. Current gain equal to output current by input current. Resistance gain equal to output resistance by input resistance. Power gain equal to output power divided by input power. Here we want to find the value of power gain. So power gain, this equation, power P equal to V square by R. Like this, we can write power gain AP equal to AV. Voltage means voltage gain here, AV square divided by resistance gain. Substitute all the values here. AV is given 50 square divided by resistance gain means output resistance divided by input resistance. Can be in reciprocal as a 50 square into what is the value of R in 100 and R out 200. 100 divided by 200. So answer here 50 means 25 into 1 by 2. So correct option is 1250. Option C 1250. This is the correct answer. Power gain has no units because output quantity by input quantity, both quantity are same, so they will cancel. No unit is there. So in this problem, power gain AP equal to 1250 is the answer. Next question. A piece of wire of resistance R is cut into n equal parts. Here a wire is there like this. Initially their resistance is R. Now these wires are cut into n equal pieces like this, n equal pieces. So what is the resistance of each pieces? R by n. R by n is the resistance of each part. Initially R is the resistance of the conductor and they will cut in equally in n parts. So each conductor having resistance R by n. If equivalent then connected in parallel, these each resistors are connected in parallel like this. The equivalent resistance of the parallel combination is R dash. Then what is the ratio of R by R dash? So R dash is the equivalent resistance of the parallel combination. So how can we calculate the equivalent resistance in parallel combination R dash? The equation is 1 by R dash equal to 1 by R1 plus 1 by R2 plus etc. Here 1 by R dash equal to 1 by R1 equal to 1 divided R1 equal to R by n, R2 equal to R by 2, that is n into 1 by Rn, R by n. So equal to n square by R. So R dash equal to, from this R dash equal to R by n square. Next we want to find the ratio of R by R dash here. R by R dash equal to R divided by, what is the value of R dash? R by n square. R by n square. R will be cancelled, so n square is the answer. N square by 1 is the answer. Option C. Next question. If the color code of carbon resistor is as follows, then given the value of its resistance in kilo ohm is, color code resistance. Color code resistance is a small resistor, but their resistance value is very high. Their resistance value is determined by using bands of colors are on the color code resistors. A color code resistor can be represented like this. Okay, here having 3 bands of colors, another band of color is there. Okay, then the value of the color code resistance is determined by using the new coded form. Okay, what are the colors are used in these color code resistors? That can understand by using this table. Okay, here colors. Generally 10 colors is the their coded form is BB Royce, Great Britain, has very good wife. She has golden silver necklace. The starting letters are represent each colors. Okay, BB Royce, black, brown, red, orange, yellow. As a Great Britain, green, blue, has very good wife. Violet, grey, then white. These are the 10 colors. Any 3 of them will make from here. Then next one, numerical values. They are numerical values. Numerical values. B corresponds 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then the power of 10, decimal multiplier, power of 10. That is 10 raised to 0, 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 4, 10 raised to 5, 10 raised to 6, 10 raised to 7, 10 raised to 8, 10 raised to 9. These are the decimal multiplier of each colors. Next, tolerance. Tolerance means percentage error during their construction. What is the percentage error their values? Here, gold, silver, no color. Okay, 5%, 10%, then 20% are the tolerance that correspond each colors. Here we can determine the value of the color code resistor by using these colors. In our question, first color is yellow. This one is yellow. Then second color is blue. Second color blue. Third color is orange. Orange. Here, then fourth color is gold. Okay. First two colors are represent the first two numerical values of the resistance. So yellow correspond numerical is 4. Then blue correspond, here blue is there, blue corresponds 6. Okay. First two color of band are represent the first two numerical values of that resistance. So 46 into next color represent their decimal multiplier. Here orange is the third color, their decimal multiplier is 10 raised to 3. Then plus or minus, gold represent their percentage error or tolerance in that value. Here gold has the percentage error is 5%. So 5% is the correct. We want to up to this ohm resistance, say unit of resistance is ohm. So here 46 into 10 raised to 3 plus or minus 5% ohm is the correct answer. But we want to express this resistance in terms of kilo ohm. So it can be written as 46 plus or minus 5% in kilo ohm. So our answer is option A is the answer, 46 plus or minus 5%. Okay, next question. In circuit shown below, the resistance are given in ohm and the battery is assumed ideal with EMF equal to 3 volt. The voltage across the resistance R4 is. Here a network is given. We want to determine the voltage across the resistance R4. So we want to find the voltage across this resistor V4. Okay. Here some options are the 0.4, 0.6 volt, 1.2 volt, then 1.5 volt. Okay. How can we calculate the voltage across the resistor? This is simply by using Ohm's law. V equal to I into R. Here V4 equal to I4 into R4. I4 represents the current through this resistor. Okay. Value of R4 is given 30 ohm, but value of current does not given here. So first of all we want to find the value of I4 from the circuit. Here 50 ohm and other resistors is given, so that effective resistance can be calculated. How can we calculate effective resistance? Here R3 and R4 or 60 ohm and 30 ohm, 60 ohm and 30 ohm are in parallel. Okay, here 60 and 30 ohm are in parallel, so their equivalent resistance 1 by Rp equal to 1 by 60 plus 1 by 30 equal to 3 by 60. From this, Rp equal to 60 by 3 equal to 20 ohm. Okay, by combining these two resistors, we get an equivalent resistance 20 ohm. Now, these 20 ohm and this 30 ohm are in series. Next step, 20 ohm and 30 ohm are in series. So their equivalent resistance Rs equal to R1 plus R2, that is 20 plus 30 equal to 50 ohm. Okay. Now by the combination of these we get the equivalent resistance of 50 ohm. That 50 ohm and also this 50 ohm are connected in parallel. Third step is 50 ohm and another 50 ohm are in parallel. So their equivalent resistance 1 by Rp equal to 2 divided by 50. 1 by 50 plus 1 by 50 equal 2 by 50. So therefore Rp equal to 50 by 2 equal to 25 ohm. Clear? And another resistor are remaining is the 50 ohm. Up to this we get 25 ohm. That 25 ohm and 50 ohm are in series. Here 25 ohm and remaining 50 ohm are in series. So equivalent resistance Rs equal to, that's the last effective resistance. So we can write effective resistance. Finally resistance. So by combining this R1 plus R2, so 25 plus 50 equal to 25 plus 50 equal to 75 ohm. This is the equivalent or effective resistance of the given circuit. So we can find the current through that circuit or current from that cell. I equal to current from that cell, I equal to V by R effective, that is 3. Voltage is in our question 3 by 75 ohm. This is the current from the circuit. Here 3 by 75 I will flow through this cell. Okay. Now this 3 by 75 ohm 75 ampere current will flow through this resistor and reach here. This has two possibilities. Some current flows through this, that is taken as I1, and also some current flows through this, that's taken as I2. Clear? Some current I1 will flow through the resistor 50 ohm, another current I2 flow through this network. Here effective resistance of this circuit 50 ohm, also here 50 ohm. We have already solved that. Two are connected 50 ohm. Two 50 ohm resistors are there, so they will equally share the current 3 by 75. So current flow through this network I2 is 3 by 75 by 2, also through this 3 by 75 by 2. Total current is 3 by 75, that equally shared through this network. So current I2 equal to current I2 equal to 3 by 75 divided by 2, that is 3 divided by 2 into 75. This is the current through that 50 ohm network. Now this I2 will be divided in two sides. Some of the current will flow through 60 ohm, another remaining current will flow through the resistor 30 ohm. So current through this 60 ohm is taken as I3, and current through this 30 ohm is taken as I4. What is the ratio of the resistor in these two networks? Here 60 ohm, also here 30 ohm is the So the ratio of resistors R3 by R4 equal to 60 by 30 equal to 2 by 1. So the ratio of the current through the I3 by I4 equal to 1 by 2. Okay. You know, current and resistance are inversely proportional. So ratio of resistors is given. The reciprocal gives the ratio of the current. We want to find the value of I4. From this, I4 can be written as 2I divided by 3. Total ratio is 1 plus 2 is here 3. So total current I. So I4 equal 2I by 3. Answer 2 into 3 by 2 into 75 divided by 3. Okay. Total current through this network is 3 by 2 into 75. By cancel this, we get 1 by 75 is the current through the resistor 30 ohm. Now substitute this value in our first equation. 1 by 75 is the current through the resistor 30 ohm. So answer is 1 by 75 into, here resistance is 30 ohm. So we get 30 by 75. So correct answer is 0.4 volt. So our option is option A is the correct answer. Okay. Check all the steps. We want to find the current through the resistor. Then we want to find the potential across the resistor by using the equation V equal to IR. Then next step, you must be find out the value of current through that resistor. For that, we want to find out the current from the cell, that is 3 by 75, that flow through this resistor equally divided, and some of them will flow through the also divided across these two resistors, and determine the current through the 30 ohm resistor and substitute this answer here. We get 0.4 volt is the correct answer. Next question. The Young's modulus of the material of a wire is 2 into 10 raised to 10 Newton per meter square. If the elongation strain is 1%, then the energy stored in the wire per unit volume in joule per meter cube is. We want to find the value of energy density here. Energy per unit volume means energy density. You know this equation. Here Young's modulus is given, and also strain in percentage also given. So our equation is energy density U equal to half into Y into strain square. This is the correct relation to determine the value of energy density by using this given data. Okay, U equal to half into, what is the value of Y? 2 into, Y is Young's modulus, 2 into 10 raised to 10 into strain. Here strain means change in length by original length, that is given in here equal to 1% is there. So what is the value of delta L by L? 1 divided by 100. Delta L by L is the strain. Here values of strain is given in percentage, so that can be changed into numerical value. So 1 by 100. So this is 1 divided by 10 raised to 2 the whole square. So 2 will be cancelled. Here 10 raised to 4 is the 10 raised to 10 is the into here 10 raised to 4. So 10 raised to minus 4 is 10 raised to 6 joule meter raised to minus 3 is the correct answer. So option A is the answer. Next question. Question number 38. An ideal gas is taken through a cycle ABCD as shown in the PV diagram. So PV diagram is given. It's a closed loop. So it's a cyclic process. The work done during the cycle is, we want to find the value of work done during this cyclic process. Okay, PV diagram. area of the PV diagram gives the work done. So here is a closed loop, so cyclic process. Area of the loop of PV diagram gives the work done for the cyclic process. So here a triangle, we want to find the work done. Work done means area of the loop of the PV diagram. Here is a triangle. Triangle, what is the area? Area of the loop gives the work done. So here is a triangle. Triangle area is half B into H. Okay, half into B means this side. So volume. How can be determined? 3V. Here volume is 3V. Here volume is V. So the difference 3V minus V into H means height. So corresponding like this. Here value is 2P. Here 2P. Value is here P. So difference is 2P minus P. So answer is here 2V into P. 2 will be cancelled. W equal to PV is the correct answer. So option D. Okay, work done here equal to PV. Next question. A step-up transformer operates in 230 volt line and supplies load of 2 ampere. Load means output current. Output current means secondary current. Current is given IS equal to, here IS equal to 2 ampere. The ratio of the primary and secondary winding is, number of turns means primary and secondary is here 1 by 25. The current in the primary circuit, we want to find the value of current through the primary circuit. What is the relation connecting these terms? Or transformer ratio, K equal to Vs by Vp equal to Ns by Np equal to Ip by Is, like that. So here by connecting this, Ns by or Np by Ns equal to Is by Ip. Okay, we want to find the value of Ip. So Ip equal to, just cross multiply this, Ip equal to Is into Ns by Np. Substitute the values here. Is here 2 ampere. Np by Ns equal to 1 by 25. So 25 divided by 1. So answer is 50 ampere. 50 ampere is the correct answer. Option B is the answer. Okay. Next, question number 40. There is a prism with a refractive index equal to √2 and the refractive angle equal to 30 degree. One of the refractive surface of the prism is polished. The beam of the monochromatic light will be retrace its path if its angle of incidence over the refracting surface of the prism is. Just we can draw a diagram about this question. Suppose say prism of refractive index √2, A, B, C is the name of this prism. AB is the one of the face, AC is another face. Suppose this face is polished. When a light ray obliquely passes from one medium to another medium, here like this, so just draw a normal here. So this one is angle of incidence I. This will be refracted. So angle of refraction is given here 30 degree. Now this just retrace by using this polished surface. That means its angle is 90 degree. No need of this that. So retrace means the refracted ray will be incident on the another face with an angle 90 degree. This is the correct. Okay. This diagram, refract index of this material is √2. Beam of monochromatic will be retraced path. Its angle of incidence over the refracting surface of the prism is. We want to find the angle of incidence I by using Snell's law. Sin I divided by sin R equal to refractive index of second medium divided by refractive index of first medium. Okay, sin I divided by sin 30, here refract angle is 30, equal to second medium is a prism, refraction is root 2, first medium suppose air of refractive index 1. So substitute the we want to find the value of I here. From this, root 2 into sin 30. What is the value of sin 30? 1 by 2. So answer is 1 by root 2. Therefore I equal to sin inverse 1 by root 2. So answer is 45 degree. So answer is option C, 45 degree is the correct answer. Next question. The two slits are 1 millimeter apart from each other. So distance between two slits are given. Distance between two slits is taken as small d, that is 1 millimeter. 1 millimeter. And illuminated with the light of wavelength. Wavelength of light is also given, lambda equal to 5 into 10 raised to minus 7 meter is there. If the distance of the screen is 1 meter from the slit, distance between screen and plane of slit, capital D is given 1 meter. Then distance between third dark fringe and fifth bright fringe will be. Okay, so Young's double slit experiment. In this, suppose a screen slit plane is there. This is slit S1, this S2. Distance between them is given small d. A light of wavelength will be emitted from these sources. It will superimpose and produce a pattern here. In their correct center, bright band is formed. Alternate dark and bright will be formed. Suppose this is a central bright. Next, a dark band is formed, and alternate dark and bright will be formed. Is the central fringe. Oh, okay. We want to find the distance between third dark fringe and fifth bright fringe. So center. So first dark, second dark. Here third dark. Distance between this third dark is taken as x3. Okay. Another and fifth bright is a first bright, second bright, like that. So we get a distance from this x5. This is a bright, this dark. Okay. How can we determine the distance between fifth bright and third dark? First you find the distance between fifth bright band from the center. Also a similar way we can find the distance to the third dark band from the center. What is the equation for that? What are the equations? For bright band, xn equal to n lambda d by d. N lambda d by d. So substitute here. What is the way? N start from 1, 2, 3, etc. So n here 5. Lambda d divided by. This is the equation of for bright fifth x5, fifth bright band. Similar way, for in the case of dark band, xn equal to n plus half into lambda d by d. Here n will start from n equal to 0, 1, 2, 3, etc. 0 correspond first dark, 1 correspond second dark, 2 correspond third dark. So equation is x3 equal to third dark, x3 equal to, here corresponding third dark is value of n is 2 plus half into lambda d by d. So here x3 equal to 5 lambda d by 2d. Okay, this is the second step. Now we want to find the distance between fifth bright band and third dark band. So distance between these two, x5 minus x3 equal to 5 lambda d by d minus 5 lambda d divided by 2d. From this 5 lambda d will divided by d is common, so 1 by 1 minus 1 by 2. Here 1 by 2 is there, 1 by 2 into this 5 lambda d divided by d. Okay, substitute all the values in this equation. 5 lambda is given, d is given, also small d is given. Substitute this value, 5 by 2 into, what are the values? Values are the small d is 1 millimeter, capital is 1 meter, 5 into 10 raised to minus 7 meter is the value of wavelength. Okay, lambda equal to 5 into 10 raised to minus 7 into capital D is 1 meter divided by small d is 1 millimeter, 10 raised to minus 3. So answer is 12.5 into 10 raised to minus 4 meter. 12.5, so 25 into 12.5 into 10 raised to minus 7, 10 raised to minus 3 in upward. Okay, this is the correct answer. 12.5 into 10 raised to minus 7 meter. So in our option, how can we convert into 1.25 millimeter is the correct answer. Options are in millimeter, so this one to convert in millimeter. So 12.5 into 10 raised to minus 1 into 10 raised to minus 3 meter. This can be written as millimeter. So 10 raised to minus 1 can be written 1.25 into 10 millimeter. This is the correct answer. Option C is the answer. The amplitude of the sinusoidal oscillating electric field of a plane wave is 60 volt per meter. Here amplitude of electric field is given. Amplitude of electric field can be written as E0. E0 equal to 60 volt per meter is given. Then the amplitude of the magnetic field is, now we want to find out the value of amplitude of magnetic field B0. By connecting these two, we can write C equal to E0 by B0 is the standard equation connecting amplitudes of electric and magnetic field. Here B0 equal to E0 divided by C. Substitute the values here. E0 equal to 60. 60 divided by C is the 3 into 10 raised to 8 meter per second. So answer is 20 into 10 raised to minus 8, or in our option 2 into 10 raised to minus 7. 2 into 10 raised to minus 7 Tesla. This is the correct answer, option D. Next, a ball is thrown up at an angle of 30 degree with the horizontal. If R and H represent its horizontal range and maximum height reached, then what is the relation connecting range and height? It's a question from projectile motion. Angle of projection is given. What is the angle of projection? 30 degree is given. Okay, maximum height H and maximum range R is given. What is the relation connecting R and H? You know, R equal to 4H. R equal to 4H cot theta is the relation connecting range and height of the projectile. So here R equal to 4H into cot theta means 30. Cot 30 equal to root 3. So R equal to 4 into root 3 into H. This is the correct answer. So option D. Next, two metal cube A and B of same size are arranged as shown in the figure.
The extreme ends of the combination are maintained at the indicated temperatures. The arrangement is thermally insulated. The coefficient of thermal conductivity of A and B are 300 watt per meter degree Celsius and 200 watt per meter degree Celsius respectively. After steady state is reached, the temperature of their interface will be. Here in our figure, two temperature is given, 100 degrees Celsius and 0 degrees Celsius. Two different metals having their temperature coefficient also given, having same size, means length and area of cross sections are same. Then it's conduct heat from higher temperature to lower temperature. After steady state means everywhere temperature will an equilibrium condition. What is the temperature at this junction? T temperature at this junction. Okay, so conductor, metallic conductor, that will allow us to flow heat through that conductor. So we can write an equation, general equation. Rate of flow of heat Q by T is equal to Ka delta T divided by L is the general equation for heat current or rate of flow of heat. Okay, from our question we want to make two equations and want to compare the two metal cubes A and B of same size are arranged as shown in the figure. Extreme ends of the combination are maintained at the indicated temperatures. The arrangement is thermally insulated. The coefficient are given. After steady state reach, the temperature of the interface will be. Okay. Here heat flow from higher temperature to lower temperature. So it will maintain steady state. In that case, two conductors will conduct same amount of heat current. So can be written as Ka delta T divided by L for first conductor equal to K2A2 delta T2 by L2 for the second conductor due to steady state. Here K1 is given, value is 300, 1 means A, 2 means B. 300, area will be cancelled because same size, length also cancelled, into delta T means temperature difference between these two ends across A. Here 100 degree minus T, 100 degrees Celsius minus T degrees Celsius equal to, here K2 is given 200 into delta T, T2 means T minus 0 degrees Celsius. Okay, by from this can be cancelled 300 minus 3T equal to 2T. So 300 equal to 5T, T equal to 300 by 5 equal to 60 degrees Celsius is the correct answer. Option D is the answer. Okay, after steady state, the rate of flow of heat through each conductors are equal. So we can write the equation. So here size of two conductors are same. So area of cross section are same. Length will be same. So they will be cancelled and substitute the remaining values. By simplifying this, temperature at the junction is equal to 60 degrees Celsius. Next question. A car moving with a speed of 40 km per hour can be stopped by applying brake after at least 2 meters. Okay, if the same car is moving with a speed of 80 km per hour, what is the minimum stopping distance? Want to find stopping distance. Okay, what is the equation of stopping distance? S equal to U square by 2A. This is the standard equation. In first case, a car moving with a speed of 40, U is given 40 km per hour, stop applying brake after at least 2 meters. Stopping distance is 2 equal to 40 square divided by 2A. This is the first case. In second case, if the same car is moving with a speed of 80 km per hour, second case U equal to 80, same car, so acceleration of the vehicle is same. At that time, stopping distance is S dash. This is the second case. Want to find the value of S dash here. So just divide these two equations. S dash divided by 2 equal to 80 square divided by 40 square. 2a will be cancelled. So answer S dash equal to 2 into 80 means 0 divided by 16. S dash equal to, how can we connect? 2 into 4. 2 into 4 equal to 8 meter is the answer. So option A is the correct answer. 8 meter is the correct answer. Next question. If the distance between Earth and the Sun becomes half its present value, the number of days in a year would have been. Okay. Here distance between Earth and Sun become halves. Initially, suppose Sun, here Earth. Distance between them is r. Earth will revolves around the Sun in a fixed orbit of radius r. Okay, in that case we can write the relation t square proportional to r cube. This is the relation connecting distance and time period. Okay, next, second case, this distance would be halved. Distance become half. That case time period is t dash square, or another way, this cancel t1, this t2 square is directly proportional to r by 2 all cube. R by 2 all cube, because initially distance is r, now is halved, so r by 2 all cube. By comparing these two equations, t2 by t1 the whole square is equal to r divided by 2 into r the whole cube, like this. So equal to, r will be cancelled, 1 by 8. So t2 divided by t1 equal to root of 1 by 8. That can be written as 1 by 2 root 2. Okay. t2 equal to t1 divided by 2 root 2. What is the value of t1? t1 is the present initial case. At their initial case, Earth take 365 days to complete one full revolution around the Sun. So initially time period is 365 divided by 2 root 2. So answer is 129 days. Okay, this is the correct answer, 129 days. So option B is the answer. Okay, next, the possible value of Poisson ratio is, theoretical value of Poisson ratio is -1 to 0.5. Okay, then practical values 1 to 0.5. So answer is 0.4 is the correct answer. Poisson ratio value lies between 1 and 0.4. So answer is 0.5. Sorry, answer is 0.4 is the correct answer. Okay. Next question. Energy stored in a coil of self-inductance 40 millihenry carrying a steady current of 2 ampere is. Want to find the energy. E equal to half Li square is the standard equation. E equal to half into L, inductance is given 40 millihenry. So 40 into 10 raised to -3 into, what is the value of I here? 2 square. 2 is the value of current, 2 square. So answer is 40 into 2 into 10 raised to -3. Answer 80 into 10 raised to -3 joule. So answer is 0.10 raised to -3. So 0.08 joule. So option C is the answer. Can be written as 0.08 joule. Okay. Here 80 into 10 raised to -3 can be converted into 0.08 0.08. So answer option C is the answer. Next question. Two identical photocathode receives light of frequencies f1 and f2. Okay, in two cases, incident radiation have frequencies f1 and f2. If the velocities of the photoelectrons of mass m coming out are respectively v1 and v2, then what is the relation connect these two velocities and their frequencies? You know Einstein's equation, photoelectric equation, velocity or incident energy h nu equal to h nu 0 plus ke max, means half mv square, half mv max square, maximum velocity. H nu 0 is known as work function, that is same for given material. It can be written as phi. Okay, it's a constant for the given material. So this equation is applied into two cases. First, incident frequency is f1. So equation H f1 equal to phi plus half into m v1 square, equation number 1. In second case, frequency is f2, h f2 equal to, work functions is same because material is same, half m into, that time velocity is v2, so v2 square. So just subtract these two equations, we get, just subtract these equations, we get h f1 minus f2, equation 1 minus equation 2. Okay, h f1 minus f2 equal to 5 will be cancelled, half m into v1 square minus v2 square. From this we want to find v1 square minus v2 square from this. Okay, v1 square minus v2 square equal to 2h by m into f1 minus f2. This is the correct relation. So option B is the answer. Okay, v1 square minus v2 square equal to 2h by m into f1 minus f2. Okay, correct option is option B. Next question, the last question from our physics. An astronomical telescope has an angular magnification of magnitude 5 for distant object. Here magnification is given 5. The separation between objects and eyepiece is 36 centimeter. That is length of the telescope. The final image is formed at infinity. So equation of magnification m equal to FO divided by FE. Two cases are there in the case of telescope. First one, image is formed at infinity. In that situation, magnification m equal to FO by FE. In another case is that image is formed at a distance d. D means least distance of distinct vision, that is 25 centimeter from eye. Okay, in that case, magnification m equal to FO by FE into 1 plus FE by d. Here, image is formed in infinity, so magnification can be written as like this. So substitute the values here. FO by FE equal to 5 is given. 5 is given, and the length between two lenses is 36 centimeter. That is known as length of the telescope. Length of the telescope in this case can be written as FO plus FE equal to length of the microscope, L equal to FO when image is formed at infinity. L infinity equal to FO plus FE. Their value is 36 centimeter. 36 centimeter. The focal length, maybe it's F. F of the objective and the focal length of F of the eyepiece are. We want to find the FO and FE. Okay, by using these two equations we can find that one. Substitute from this FO equal to 5 FE. Just substitute here, so we can write in the place of FO, substitute 5 FE plus FE equal to 36 centimeter. So 6 FE equal to 36 centimeter. FE equal to 36 by 6 equal to 6 centimeter. Here focal length of eyepiece FE equal to 6 centimeter. Focal length of eyepiece equal to 6 centimeter. So next we want to find the focal length of objective. Substitute here FO equal to 5 into 6, that is 30 centimeter is the answer. So correct option D is the focal length of objective lens is 30 centimeter and focal length of eyepiece FE equal to 6 centimeter is the correct answer. This is all about our physics comparatively easier questions, and also it's similar questions from our NEET exam. So prepare very well and make a confidence. Okay, all the best.